Okay, again, welcome back. So here we are going to discuss another menu of the calculator, the equation and function. Okay, so we're going to discuss a problem involving quadratic function. So our problem is this one. A ball is thrown vertically upward and the height h in meters of the ball is given by the equation h of t is equal to negative 4.9 t squared plus 17.6 t plus 2 where t is in seconds. These are some possible questions. Number 1. What was the maximum height reached by the ball? Number 2. At what time did the ball reach the maximum height? And number 3. After how many seconds did the ball hit the ground? Number 4. For how many seconds did the height of the ball above 15 meters? So here is how we solve this problem. So to analyze the problem, we can construct a graph between a height and time graph. So assume that the ball starts at 2 meters. So the ball starts here. Then it was thrown vertically upward. And of course, the time is running. So the graph is a parabolic graph. So as you can see, at this point, this is where the ball reached the maximum height. And that is related to the value of k. And the time here, where the ball reached the maximum height, is given by h. Okay? And for us to be able to answer number 3, after how many seconds did the ball hit the ground, we just have to find the time here. Because this is the time after throwing the ball hit the ground. And for the last problem, we have to know for how many seconds did the height of the ball above 15 meters. So, if this is 15 meters, we just have to find the length of time from this point up to this point. So, how are we going to solve these problems? So, to be able to answer the first problem, we have to go to the menu of the calculator, the equation or function. Menu, go down. Here, press equals to access that. So here we go. Since the problem has something to do with quadratic function, we have to press polynomial. And then the degree of the quadratic function is degree 2, so press 2. So here we go. So we just have to input the coefficients of the function. So for a, we have negative 4.9. Press equals to execute. We have 17.6 for b. That's positive. Then equals again. And then for c, we have positive 2. So press 2. Alright. Then press equals to be able to get the first value. Then it will give you another value. Press equals x sub 2. And then press equals again. Another value is just x. So, to change this to decimal, you can again press SD. Alright? And then another equals for the last value. Press SD again. That is 17.8. As you can see, the calculator gave 4 values. What are those 4 values for? So, let's go back. Another equals again. The first value is actually the time. Then, the next value is also another time. If we are going to go back to the graph, you can see there, the 2 points on the x-axis are these 2 values. These are also known as the roots or the zeros. Next. Then this value of x here, as you can see, it will give you maximum of y equals ax squared plus bx plus c. And that x is 88 over 49, which is 1.79. This one means this is the time where the ball reached the maximum height. And this is the answer for the second question. And the last value, y, is equal to 4362 over 245 or 17.8 is actually the maximum height reached by the ball. So the answer for the first question is 17.8 meters. Okay, so for the third question, after how many seconds did the ball hit the ground? So the answer for that is, looking back at x sub 1 and x sub 2, of course, we don't have negative time. because the ball starts, or the first height of the ball is at 2 meters. And this is not what we need. So the ball hit the ground after 3.7 seconds. So that's the answer for question number 3. Okay, to solve problem number 4, for how many seconds did the height of the ball above 15 meters, we don't have any key in the calculator that will give you the direct answer. So as you can see from the illustration, if this is the 15 meters, since we know that the maximum height of the ball is around 17 meters, so the ball reached the height 15 meters at some points here and some points here. So to be able to determine the number of seconds or the elapsed time where the ball is above 15 meters, we just have to find the time here and also the time here, and then eventually subtract them. So how is that? So from the equation, negative 4.9 t squared plus 17.6 t plus 2, we just have to equate it to 15. Because the height that we want is 15. And then from here, we can have negative 4.9 t squared plus 17.6 t minus 13 by subtracting 15 to both sides is equal to 0. And this equation is the one that we're going to solve under the equation or function menu. Okay, so as you can see, we already input negative 4.9 and 17.6. So we just have to change the last value, which is 2, to negative 13. So we can put minus 13 or negative 13, then equals. And then from there, we just have to solve the 2 time or the number of seconds where the height of the ball is above 15 meters. So press equals. This is the first time where the ball reached the 15 meters, and that is around 2.55 seconds. And then the next time is at 1.0394. Meaning to say, at 1.04 second, the height of the ball is at 15 meters here. And then another time, at 2.55 seconds, the height of the ball is here. Therefore, to be able to determine the length of time where the ball is about 15 meters, we just have to subtract this. And of course, we can just easily subtract 2.55 by 1.04. And the answer is 1.51 seconds. So this is the length of time where the ball is above 15 meters. So that's the answer to our problem. But wait, there's more. As you can see in our problem, the value of a here is negative 4.9. And as we go along pressing equals, we can see that it will give a maximum value. Now, let us try to change the value of a to positive value. So let's try to make it positive 4.9. So go down, equals, equals. And as you can see, now this time, it will give you a minimum value. So what does it mean? The calculator will also tell you if the function has a maximum or the function has a minimum value. And that ends our lecture about quadratic function using the Casio calculator. Please watch the next video. Bye-bye!